Okay, today's lesson we're going to continue talking about trig ratios. So yesterday we talked about sine, cosine, and tangent. We're going to mention the other ratios that we can find concerning a right triangle. So we have a few more. Then we're going to talk about converting between radians and degrees. So radians are just another way to measure angles, just like we have inches, feet, yards, meters, all sorts of different ways to measure length. We have different ways to measure angles as well. By different ways, I mean different units. Okay, so we have different units of measurement for angles, and we're going to talk about how to convert between them today. Alright, so first of all, here, it looks like a lot here, but these first three we talked about yesterday. Okay, and with all of these, remember we're talking about this kind of a right triangle. There's an angle. We have the opposite side, the hypotenuse, and the adjacent side. So these ones below, the ones below the three that we talked about yesterday are kind of the inverses of these. So I flip sine. So instead of opposite over hypotenuse, now I have hypotenuse over opposite. Okay, and we call that cosecant. Okay, so practice saying cosecant. That's what this is called. It's abbreviated CSC. Okay, so we think of it as kind of the flipped or the reciprocal of sine. And so we can write it as hypotenuse over opposite, or we can write it like this, 1 over sine, right? That's exactly the same thing, just another way of writing it. And then same thing for secant, okay? This word is secant, and it's the inverse of cosine, or the reciprocal, I guess. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. Okay, and since this is just like over 1, we could also think of it as taking the reciprocal of that, so it's just 1 over cosine theta. And with tangent, same thing, we have cotangent, that one's named nicely. It's just flipping that, so we get adjacent over opposite. Alright, so for these, I had students try to write these on their own, starting with sine, cosine, and tangent for number 1. So let's go ahead and look at what those measurements would be. So for sine, remember sine is just opposite over hypotenuse, so I take 5 over 13. Cosine is adjacent. Remember, adjacent is the side that this angle is touching. Okay, so the angle is touching the hypotenuse and a leg. The adjacent side is the leg that it's touching. Okay, the hypotenuse is always the hypotenuse. Alright, so cosine is 12 over 13. And tangent is 5 over 12, opposite over adjacent. Okay, so now we're going to flip them for these new trig ratios that we have. So cosecant is just the reciprocal of sine, so this is going to be 13 over 5. Secant is the reciprocal of cosine, so I get 13 over 12. And then cotangent is the reciprocal of tangent, so this is 12 over 5. Okay, and then continuing on, if you're doing this for the first time, try to pause the video here and come up with these 6 trig ratios for number 2. Okay, here's what you should get. So sine is 3 over 5, cosine 4 over 5, tangent 3 over 4. And then those flip. So we have 5/3 for cosecant, 5/4 for secant, and 4/3 for cotangent. Okay, we don't really have to simplify. So here where it's 5/4, you could really write that as 1 1/4, but for our purposes, leaving it as an improper fraction is totally fine. Okay, over here, this last one, number 3. This is one of the special triangles that we talked about yesterday. It has a 45-degree angle here, so it's a 45, 45, 90. And the hypotenuse is 1, so we calculated, yesterday we talked about how to calculate that these are the side lengths. Okay, but let's look at all these trig ratios for this triangle. So the sine of theta, or which in this case is 45 degrees, right? It's given to us. So sine of 45, I do opposite over hypotenuse. That's going to give me root 2 over 2. And cosine is very similar, right? Adjacent over hypotenuse is just root 2 over 2 over 1. Tangent is opposite over adjacent, so remember that's from yesterday where we have the same thing being divided by itself, so that's just 1. Cosecant here is going to be sine flipped, or the reciprocal of sine, so I have 2 over root 2. And I need to rationalize the denominator, so I get 2 root 2 over 2, and that simplifies to just root 2. Since that's the inverse of sine, and cosine and sine are equal, if I take the inverse of cosine, it should be equal to the inverse of sine. So if I were to do this, I would flip, I would have this same math happen. Okay, do you see that? Because this is cosine flipped also. Okay, so the same math happens, and we get square root of 2 for secant. And then cotangent is 1. You can think of that as 1 divided by 1. So flipped, it's still 1 divided by 1. Or here on the graphic, we would do adjacent over opposite. Okay, so it's the same thing where we have the number over itself, so that's why it's 1. Alright, so that's just kind of a little overview of these 6 trig ratios. There's going to be some problems like this on your homework. Pretty straightforward, all the sides are given to you. If there was ever a case where you didn't have all the sides, you could still do these for a right triangle. Anytime you're given 2 sides, you can come up with the third using the Pythagorean theorem, right? We also have these special triangles, so sometimes if you're just given 1 side and an angle, you can figure out the rest of the triangle. Alright, so let's move on now to the second portion of our lesson, which is going to be converting between radians and degrees. So again, this is just another way to measure angles. It's another type of unit that we use, just like how sometimes we measure using feet or inches, or maybe sometimes we use meters, so those are really different, right? Feet and inches, we just kind of multiply or divide by 12. If you have something like feet to meters, it's a little weird, or feet to centimeters, you have to kind of do a little more work there. This isn't too bad for radians and degrees. We just have to multiply by this conversion factor, and it's either pi over 180 or 180 over pi, depending on which way you're going. So here I like to think of this as what do I need to cancel out. Here I want the degrees to cancel out, so when I line it up this way, I can cross-cancel the degrees. Okay, and I'm left with some number times pi over 180. And pi here, the units for pi are really radians. So it gives you radians as your unit at the end there. Okay, and then same thing here when we're going to from radians to degrees. This degree sign is not going to cancel with anything, and the radians sort of cancels out with the pi down here. Okay, so you just get a number times 180 degrees, and you're left with the number of degrees. Okay, so that will convert for you. Okay, let's do some practice problems with these conversions. So here's the first 2 examples. Number 1, if I had 30 degrees, I'm multiplying by pi over 180, right? Those degrees are going to cancel out. I have 30 pi over 180 then. Okay, and I can reduce here, right? 30 goes into 180 6 times, so I'm left with pi over 6 radians, or I can abbreviate it to just RAD, or rad. So pi over 6 rad, or radians. Okay, so I know now, just like how feet and inches, if I say 1 foot is equal to 12 inches, even though those numbers aren't equal to each other, the units, they represent the same length. So these represent the same angle. 30 degrees and pi over 6 both represent an angle kind of this big. Okay, so both represent 30 is the same as if I put pi over 6. Okay, and I should actually be precise here. From here on out, really, anytime that you are going to talk about degrees, you really need to make sure you put that degree sign because typically we don't even put units for radians, so we assume if it's just a number that you're talking about radians. So if you're going to be dealing with degrees, make sure that you put the little symbol. Alright, so number 2, pi radians, and I'm going to convert that to degrees, so I have pi. And to get this to cancel out, I want to be multiplying by 180 over pi. So the radians cancel out, and in fact the pi cancels out as well, so I'm just left with 180 degrees. This actually kind of makes sense because our conversion factor is 180 over pi, right? So this is saying there's 180 degrees in pi radians, just like how sometimes we would multiply by 12 inches if we had like 3 feet and I want to know how many inches that is. I'm really multiplying by this. It's really like 3 feet times 12 inches divided by 1 foot, because this is just like 1, right? That's why you can just multiply it and what you get is equal to what you started with, because these two things are equal. So the fact that that's our conversion factor should tell you that pi radians and 180 degrees are equal. Alright. Okay, so moving on to some examples that the students did now. Okay, numbers 3 and 4. So again, converting the first one to radians and the second one to degrees. So 150 degrees here, I'm going to multiply by pi over 180. Again, I put it this way so that the degrees cancel out. Oh, sorry about that. So I'm left with 150 pi over 180. I can reduce that by 10, so I get 15 pi over 18. And I can reduce this more by 3, so I get 5 over 6, with pi in there, of course, so it's 5 pi over 6. And then number 4, converting to degrees, so 3 pi radians, or 3 pi over 2, excuse me. I'm going to multiply by 180 over pi, so that my units convert to degrees, because the radians cancel out. The pi actually cancels out as well, so I have 3 times 180 divided by 2. 2 goes into 180 90 times, so I simplified there. And I'm left with 270 when I multiply across. Okay, here are a couple more examples. We didn't do these two in class, but I will show them to you now in case you're having some difficulty on your homework. Alright, for these last two, so we have 45 degrees. I'm going to multiply that by pi over 180 so that the degrees cancel out. So I have 45 pi over 180. I can divide both of these by 9. So I get 5 pi over 20, and I can actually reduce this even more. I can reduce that by 5, so I have just 5 goes into 24 times, so I have pi fourths. Okay, so pi fourth radians would be my answer here. Okay, for number 6, to convert to degrees, I'm multiplying by 180 degrees over pi here. The radians then would cancel out, and I also have pi's canceling out. So that gives me 7 times 180 degrees over 4. I can reduce this by 4, and that gives me a final answer of 315 degrees if you do 7 times 45. Alright, so that's it for today's lesson. Go ahead and try the homework. There's some problems with the different trig ratios and then converting radians and degrees. I'll see you guys tomorrow. Thanks.